I've seen every time students, they struggle with this matrix. Okay, this is called jump chain matrix. This is normal transition matrix. This is generator matrix. There is a third one also, and we'll try to connect this one with generator matrix. These two, there is a connection between this and this. Is there a connection between this and this? That is my question. Weighting, assessment, minor, severe, home. Weighting, assessment, minor, severe, home. Now suppose I am waiting. Now I am in the waiting state. Okay, I am on road, I am waiting, and I want to get the service. Okay, they will check my car, whether my car is in proper condition or not. They will check. Now I am in the waiting state. Once I leave waiting state, where I will go? If I leave waiting state, where I will go? Yeah, A, 100% probability. I am talking about probability now, not generator matrix. The probability that once I leave W, I'll go to A. Remember, when I talk about this matrix, if these are the 5 states, this concept is very important. Okay, if you do after a certain time, if the time interval is constant, you do after a particular duration of time, then that is your transition matrix. Okay, these are the PIJs. And what are mu ijs? If you consider very small time gap, these are mu ijs, these are the rates. But we are not considering these two here. What we are doing here, we are doing something different. What we are doing here is, once we leave this state, okay, I am in the waiting state now. Once I leave waiting state, it could take this much time. Where I will go? There is a 100% probability that I will go here. So this is my waiting time, then I will go here. So this waiting time, it could be anything. Okay, but we have average given 15 for each one, average, but this follows exponential distribution. Now from here to here, that could be different. Okay, if I leave this, the second one, suppose I will leave, so others will be 0. We are talking about probabilities. How about this? Now I am in the minor state. If I leave minor, I will go to home. If I leave severe state, I will go to home. Okay, if I leave A, then I am not sure. Okay, obviously I will not go here. From assessment taking place, I will not go to waiting once again. They will not send me here. And from assessment to assessment, okay, probabilities. Now these 3 probabilities will come. They've given 80%, 80%, they will go home. So I'll write 0.8 here. And 15% minor, okay, minor 15%, and major 5%. Okay, the total probability is 1 year, total probability is 1 year, total probability is 1 year, total probability is 1 year. Okay, then we'll write 0 0 0 0 0. Okay, if you say I'll make it 1, total probability is 1. This is a kind of matrix. Once again, total probabilities are 1, but this is not going from here to, suppose, this to this in one time step. We are not talking about one time step. These are not the PIJs we come across. These are these PIJs. That means there is no time duration here. When we say today, tomorrow, when we say today, tomorrow, this applies for all the times. Today, tomorrow, tomorrow, day after tomorrow, there is a constant time duration. We are not talking about time duration. What we are saying here is, when we talk about capital PIJs, the jump chain probabilities, these are the probabilities when we leave states. Once we leave waiting state, where we will go? There is a 100% probability that you will go to the assessment. We never go to minor, we never go to severe or home. When we leave assessment, these are the probabilities. Okay, you can go anywhere, but these three, not these two. When you leave minor, you go here. When you leave this one, you go here. H to H 100%. Now what we do is, when you try to get generator matrix from this one, because generator matrix is important in this chapter. To get generator matrix, what we do is we apply this formula. Mu ij's, these are p ij's, capital P ij. So lambda I p ij, I think lambda j p ij. This is the formula. Okay. So we'll multiply lambda 1 to this row, lambda 2 this row, lambda 3 to this row, lambda 4 to this row, lambda 5 to this row.
So the first matrix that we've made, that's essentially a transition matrix, right?
Which one? This one?
The one with the probabilities.
This is,
or is it jump
chain matrix, not transition matrix.
Okay.
Yeah. From jump chain matrix, we'll try to get the generator matrix. Okay. Yeah. So how to get generator matrix from jump chain matrix? Here we will apply this formula. So lambda 1 is given. Where is lambda 1? Waiting time, sorry, 15 minutes. Okay, we will multiply 1 by 15 here. If you multiply 1 by 15, you will get this way: 0, 0, then 1 by 15, 0, 0, 0. And remember, these are not for the diagonal ones. These are for the non-diagonal entries. Diagonal elements will deal with them separately. Okay. So W to W, for example, these 5 will handle separately. So we are not applying for these elements. We are applying for non-diagonal elements. Similarly, you do for the second one, lambda 2. Lambda 2 was I think 1 upon 20, if I am not wrong. So we'll multiply 1 upon 20 to this one, we'll get 0. Anyway, we are not doing any one. Let's write star. And this entry, when you get 1 upon 20, 0.5 divided by 20, 0.05 divided by 20, you can match with the last one, whatever way we found. Then multiply lambda 3, 30 minutes. The first one was 20, then 15. I wrote 15, assessment 20. Okay, assessment 20. Then here 30 minutes. Okay. Where are the waiting times? Let me start with this one. Okay, 15, that was correct. Then I have taken 20. Okay, you multiply 1 upon 20, I got it. Then here minor fail 30 minutes. Okay, this is 180, I got it, 30. So you multiply 1 upon 30 here. Two non-diagonal entries, 1 upon 30. Okay, then 1 upon 180. Then these are 0, 0, last row anyway. So what will happen is, when you multiply 1 upon 180, 1 upon 30, 1 upon 20, 1 upon 50, you will get all non-diagonal entries. For diagonal entries, we have formula. Mu yi is minus summation mu ij, j is not equal to I. We will apply that. That means if this summation is 1 by 15, we will write minus 1 by 15 here. That way we will find all the entries of this generator matrix. Okay, this is one way. So you find capital Pij's, the jump chain matrix probabilities, multiply lambda I, the rates, to get this. Okay, this is the first problem. So from jump chain matrix we'll get generator matrix. From generator matrix we'll get these transition matrix. Okay, that means the transition probability, small Pij's. I can write these as big pij's. I've written here. These are mu ij's. Okay, from mu ij you can get small pij's. Okay, and how can you get? Through Kolmogorov equations. There are 4 types. Okay, we are now using only forward differential equation. There are other 3 types.